Question number 12, worksheet work, power, energy. A car of mass 1250 kg travels from bottom to the top of a straight hill whose length is 600 meters, which is inclined at 2.5 degree to the horizontal. The resistance to the motion of the car is constant and is equals to 400 newtons. The car is going upwards, so the resisting force is going to be downwards. The work done by the driving force is 450,000 joules. So work done by driving force is given. The speed of the car at the bottom of the hill is 30. Find the speed of the car at the top of the hill. Okay. I would like to use a conservation of energy formula to find the answer. So work done by driving force plus loss in energy is equals to work done by resisting force plus gain in energy. Okay. Work done by driving force is known for 50,000 plus losses in energy. Potential energy is clearly increasing. So we'll have PE over here. Kinetic energy, I'm not sure yet whether the speed here will become greater or will the speed here will become smaller than 30. So let's hold on to that. Okay, let's look at the right hand side. Work done by resisting force. Okay, so since the resisting force is given, and also the distance of this slope is given. So we're going to use the work done formula F times D. So if we have the resisting force and the distance it covers, we can find the work done by resisting force, which is going to be 400 times 600 plus gain in energy, which is clearly the potential energy since the height is increasing up the slope. It's going to be mgh, where h is the change in height. M is 1250, g is 10, h would be this length, which will be, this is 600, this is 2.5, so the opposite component is 600 sine 2.5. So H is this 600 sine 2.5. Okay, now let's come back to the concept that is kinetic energy increasing in this system? If it's increasing, we will write its value over here. And if it's decreasing, then we write its value over here. Okay, so let's try to figure that out. Okay, looking at this slope, driving force would be here, and this component of weight is mg sine 30. Okay. Now, if the driving force is bigger than the sum of these two, that would mean that this car is accelerating upwards. And if it's the other way around, if mg sine theta plus 400 is a bigger value than the driving force, that would mean that this car is decelerating. So let's see, what do we have? Okay, so uh, how do I find the driving force? Okay, so we have the work done by driving force given to us in the question, which is this. Also, we have the distance, which is 600 meters. I'm using this to find the driving force. So work done by driving force is equals to F times D. F is the driving force. So 450,000 divided by the distance covered, which is 600, should give us the driving force. What is that? That's 750 newtons. Now let's check the sum of 400 and mg sine theta. 400 plus mg sine theta, which gives 945.24. So since the downward force is bigger than the upward force, so that means the particle is decelerating, which means there's going to be a loss in kinetic energy because the speed decreases. So this is loss of kinetic energy. So we write half times m 1250 times bigger speed squared. So bigger speed is going to be 30 minus smaller speed squared. Let's call it v. And now we solve this to find this value of v. This comes out to be 26.7.